All right, so we have talked about the fundamental theorem of calculus for a few days. Now we're going to look at the second fundamental theorem of calculus. So if we have some function, right, whatever this function is, right, so this is f, and we want to integrate, we want to find the area under the curve from a to some value x, okay? So remember that accumulation, that integral, that represents an area under the curve. Sometimes we straight up find area. Sometimes we have other ways of looking at that. But, so if I have, so my fundamental theorem of calculus then says this. If I integrate from a to x, okay, instead of a to b, so if I have a to x of f of t dt, okay, and now, let's pause here for just a second, because what I'm about to say, once we do this more and more, it'll make sense. But I want you to notice that a lot of times we're talking about f of x dx. This variable really could be anything except for x, okay? And this is one of the things that you can get nailed on the test, is that if I'm going from a to x, this variable cannot be x, okay? It has to be something else because we're going to substitute it in. Okay, so just know that they have to be different. So our fundamental theorem says, if we integrate, that is the area under the curve. That is the accumulation of change. How much did it change? So if that's lowercase f, right, that means it's been taken the derivative of, that's equal to f of x minus f of a, right? And those are capital. So it's the final minus the initial amount. That's what we've got, right? So if it's, how much water was added to my bucket. I take what I ended with minus what I started with. That's how much was added. That's also what this would be, depending on what we're trying to do. You with me? Okay, so notice what the second fundamental theorem says. We have this, okay, but then we're taking the derivative of it. So we're going to take the first fundamental theorem of calculus, and we're going to take the derivative of it. So we're going to take dx of both sides. Everybody with me on that? So if I take the derivative of capital f of x, what do I get? Lowercase f of x, right? That's like going from f to f prime. Make sense? Then minus f of a, this is some constant. What's the derivative of a constant? 0 minus 0. So that means that this whole thing here just equals f of x. See how that works? Now, and let's remember, if we have f, capital F, then lowercase f, f prime, f double prime, that's how, like the sequence of derivatives, right? It's fine to still start with f like we have before, but when I integrate f prime, that gets me to f, little f. And if I integrate little f, that gets me to big F, right? And then we know how to go the other way. You can either go from big F to little f, or you could also go from big F to big F prime. So I'm going to use that sum today too. It's the same thing, okay? So that means that what this is saying here then, if I'm going to integrate some function from some constant a to some value of x that would be on my x-axis there, and I take the derivative of that, the derivative is the inverse of the integral, right? So it's like squaring a number and then taking the square root kind of thing. And so this is just going to equal f of x. So all you do is you take that x and you substitute it in for t. That's all we're doing. Now, look at this one. How is this one different than this one? The a and the x are flipped. How do we flip them around? Negative. So this is equal to negative f of x. Everybody good with that? Okay. So I'm going to take the derivative of the integral from 1 to x of t squared dt. Okay, so I'm going from some constant, and the constant's irrelevant because when we take the derivative, right, it's just going to be 0. So the from 1 to x, so I just substitute that in, and that's going to give me x squared. Taking the derivative of an integral from a constant to x of cosine of t dt, just going to take this x, and this becomes cosine of x. Will this one become x squared? No, because the x is on the bottom. Oops, I don't know what I meant to do that. So this x does get substituted in here for the t, but we have to flip it around, so that's going to be a negative x squared. Okay. Everybody okay with that? Any questions so far? So that's if we're just going from some constant to x. There's also the second fundamental theorem with the chain rule version here. So let's look at what this looks like. So let's say that we are integrating from a to g of x instead of x, of f of t dt. Okay. So that means that's equal to, so just as the fundamental theorem goes, I don't have any derivatives on here yet, I'm going to take the final minus the initial, so that's f of g of x minus f of a. Final minus initial, right? Everybody with me so far? So now I'm going to take the derivative of both sides. So the derivative of big F of g of x, chain rule. Chain rule says we take the derivative of the outside. Remember, we're eating those suckers from the outside in. So the derivative of big F is little f. So little f, and you leave the inside alone, times the derivative of the inside, which would be g prime of x. Right? That's your chain rule. Derivative of the outside, leave the inside alone, times the derivative of the inside. Then minus, this is the derivative of a constant again, so again, that's just 0. And that's why all of this equals this right here, and that's what this already says. If I take the derivative, this time instead of going from a to x, I'm going from a to a function of x. Then I get f of g of x times the derivative of g of x. What questions we got? All right, so let's try that. I'm taking the derivative of an integral that's going from a constant to a function of x. So this x squared does get substituted in where you see the t. So this is going to give me cosine of x squared. But then I have to multiply that by the derivative of x squared, which I could put out here, but I like to put them in the front. What's the derivative of x squared? 2x. I just put it in the front just because it makes more sense. We good with that? What questions you got? Because we are taking the derivative, basically, of big F of g of x, and it's the chain rule. So it's f of, we substitute this in just like we had before, right? But then we also have to take the derivative of what's the inside, whatever that function is. Does that help? Okay. All right, so we're going to use the second fundamental theorem here. Let's look at A. Is A going from a constant to x or to a function of x? It's just from a to x, right? X is just x. So I don't have to worry about the chain rule thing, right? All that happens, x is in the top, so the sign stays the same, is that x gets substituted in where you see t, and that's the square root of 1 plus x squared. Same thing here. We're taking the derivative of an integral from a constant to x. This x gets substituted in here. So this becomes the tangent of x cubed. And that's all I've got to do. Here, I'm going from a constant to a function of x. I still substitute it in just like I've been doing. So that's equal to 1 over 1 plus, is that x cubed? It just looks like a blur up here. Yeah, okay. 1 plus x cubed. And then I multiply that by the derivative of x cubed, which is what? 3x squared. Okay, and I could leave it like that, or that would just be 3x squared over 1 plus x cubed. Could I simplify those x's? No. What questions do we have? Ask me a question. All right, go ahead. Mm-hmm. Yes. So notice every single time we take x or the function of x and we substitute it in where t is. That happens every single time. If it's just plain old x, then really it's also the same steps. What's the derivative of x? 1. So we're really multiplying by 1. We just don't do that. So you're kind of doing the same steps every time. You just don't need to say I'm going to take the derivative of x and it's times 1. So after you substitute it in, if it's not just x, or you can think, do I need to take the derivative? Then you take the derivative, you multiply it also. Okay? Is that good? All right, so here, this is clearly not x, it's a function of x, but the first thing I do is I substitute it in. So I get the cube root. Actually, I'm gonna move over a little bit so I can, when I take the derivative of this, I can put it in the front. So the cube root of 1 plus, so when we square sine x, let's think about how we write that. We don't really write sine x and then square it. Sine squared x, yeah. Sine squared x, okay? So I substituted it in there. Then I need to take the derivative of sine. What's the derivative of sine? Cosine. So then this is cosine x. What questions do you have? I think next time I teach this, I'm going to teach the chain rule the opposite way, going from the inside out, because we always write the second part in the front anyway. Remember I asked y'all, like right after I taught it, I saw somebody and somebody was like, they did it backwards. I was like, that makes so much more sense, but I didn't want to confuse y'all. So still keep doing it in this. That looks like cosine x cubed. Okay. You know that it's not, right? That's cube root. And this was cosine x times, there we go. That looks better. We good? All right. All right, so we want to find f prime, big F prime of x. Means we're going to take the derivative of both sides, right? So basically we are taking the derivative, again, the derivative of an integral from a constant to x. So f, big F prime of x equals, and so this, the step I'm not writing is writing d dx in front of all of them. We don't need to do that every single time, but that's what we're doing. So since we're taking the derivative of that, take the x, substitute it in, not where the 2 is, substitute it in where t is, x plus 2, and then take the derivative of it, which is just 1. Okay. Everybody good with that? All right, so that means here, f prime of x, big F prime of x, constant to a variable, substitute it in, that's secant squared x. On C is all I'm doing substituting in x, because it's got to flip these around, right? And to flip those around, it's going to be negative. So f prime, big F prime of x, equals negative, and then I do substitute in x everywhere I see a t. Need my parentheses there. X squared minus 2x plus 5. So I could leave it like that, or that is negative x squared plus 2x minus 5. What questions do you have? All right. Zig D. F prime of x. What does E stand for? Easy. Okay, so the first thing we do is we take whatever that is and we substitute it in for t, right? So that's going to give me e to the x times cosine of e to the x, right? That's not just x, so then I need to take the derivative. What's the derivative of e to the x? E to the x. So I've got to multiply it by e to the x. So it's e to the x times cosine of e to the x. We can leave it like that, but remember, we're going to make sure we know how to handle things like this, because if it was a multiple choice question, we may get a different version of that. I can't combine this one with these two because that's all one piece, right? But I have I have e to the x times e to the x. What do you do when you add, well, I just gave it away. When you multiply the bases, you add the exponents, right? So e to the 2x, times cosine of e to the x. So it'd be fine to leave it in that first step, depending on what you're doing, but you need to be able to recognize the other as well. Okay. Any questions? All right, so now, what do you think about this one? Do I have to negative it? Why? No, you don't. That's fine. Okay, x is at the top, so that's good. All I do, this is easy. This is just the sine of x squared, which is different than sine squared x that we did, right? Okay. So then let's look at f. I'm going from a constant to a function of x. So the first thing I do is substitute that in. So this is going to be cosine squared x minus 25 to the third power. And then I have to take the derivative. What's the derivative of cosine? Negative sine. So this is negative sine x times that. What questions do we have? Okay. This tells us to find f a double prime. So, to find f prime of x, right? F prime of x, I'm going from x to 7. So what's the first thing we notice? Negative sign. I'm going to have to flip those around, right? So this is going to be negative cosine squared of x minus 5. Now, that's f prime. I want f double prime. Would it be helpful to rewrite this a little bit before I did that? The answer is yes, if you remember doing these derivatives. So I'm just going to say again, f prime of x equals negative, and then cosine of x minus 5 squared. Isn't that the same thing? Like, this is the way we write it, but this is what's really happening. And I think it's good to see that, so that when we now take the derivative of it, we know we have to use what? What rule? Chain rule, because I have a function inside of a function, right? So that means that f double prime of x equals, so I take the derivative of the outside, so 2 comes out front, so I'm going to get negative 2 times, and then I leave the inside alone, cosine of x minus 5. That reduces that exponent to 1, so I'm not even going to bother putting it, right? Times the derivative of the inside. What's the derivative of cosine? Negative sine of x minus 5. And then it would also be times the derivative of this inside, but what's the derivative of what's in here? 1, so I really don't have to put that. So in the end, what I have, I could leave it like that, but f double prime of x is equal to a positive 2 times the cosine of x minus 5 times the sine of x minus 5. You don't hate it here. Okay, what color is that? I took it over here to save it for you and then I lost it. Oh no, you kept it, that's right. I forgot. I was like, I just took that and I don't know what to do with it. All right. Everybody good? What questions we got? Okay, so we have big F equal to this integral, right? That's going from negative 5 to x. Now, in what we have written here, nothing here tells us to substitute or derivative anything, right? But it says, on what intervals is f decreasing? How do we figure out when f is decreasing? The fun chart, our fun box. So remember, so in this case, this would be f, little f, and then f prime, right? So it's fun, and then this is up and then down. So this is up and then down, positive, negative, positive, negative. There's your fun box. Okay. Big F is decreasing. We're looking at this right here. Big F is decreasing when little f is negative, right? So do we know little f right now? No. Can we find it? Yes. I can just take the derivative of both sides, right? So when I do that, I get that little f of x is equal to, all right, so I'm going from a constant to x. Do I need to flip it around and make it negative? No. So I can just substitute in my x's here, and I get x squared minus x minus 6. So what do I do next? How am I going to figure out when this is negative? I get my zeros and make a sign chart. So I'm going to set this equal to 0. I should be able to factor this very easily. So this will be x minus 3, x plus 2. So my x's are a negative 2 and a 3. Make my sign chart, negative 2 and 3. Right, so if I substitute in a negative 3, that's going to give me negative times negative, which is positive. I can substitute in 0, so that's negative times positive, which is negative. I can substitute in 4, that'll give me positive, positive, and positive. And I want when f is decreasing, so that means when little f of x is less than 0. That's what this is right here. So remember how we had to write our answers? We can say f is decreasing on the interval negative 2 to 3 because, why? Little f of x is less than 0. Or little f is negative. That's fine too. Same thing either way. What questions do we have? Okay, so taking the new stuff we learned, making sure we still know how to do our old stuff with it, right? Okay, so it says write the equation of the line tangent. So write the equation of the line. As soon as you see that, you just say, okay, I need a point and I need a slope. Okay. A tangent to the graph of y equals 3 minus the integral, blah, 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 at the point where x equals negative 1. So I know that for my point, my x value is negative 1. I need a y value. So if this is y, I can take negative 1, substitute it in for x, and I'm going to integrate something going from negative 1 to negative 1. What's this value going to be? 0. So it's 3 minus 0, which means my y value is just 3. Does that make sense? The slope I have to get from what? F prime, okay? And we called this y, so we'll have to dy dx. So yes, I mean, you were right, that was fine. But dy dx equals, all right, so the derivative of 3 is what? 0. And then we have minus, so it's minus. Then the derivative of this, I'm going from negative 1 to x. X gets substituted in there, so it's negative e to the negative x cubed. Everybody with me so far? Then I need to find dy dx evaluated at x equals negative 1, right? So that's equal to negative e to the negative 1 cubed, right? What's negative 1 cubed? Negative 1. Make that negative, that's positive 1. So this is just negative e. That makes sense? We all good? So don't be afraid of the e's. It looks weird. Most of the time when you come, it's going to come out nicely. Even that integral, I mean, it just ended up being 0. So my slope is negative e. So the equation of my line then is y equals the slope, which is negative e, times x minus the x value, so that's x plus 1, and then plus 3. There's the equation of my line. What questions do you have? All right. So this next one looks like multiple choice, but it's not. I know. Look at all this work. Okay. So we're going to find all these things. So for A, we're looking for f prime of x, big F prime of x. So that means we take the derivative of both sides. I'm taking the derivative of an integral that goes from a constant to a function of x. So this does get substituted in everywhere we see a t. So that's going to be equal to, I'm going to leave a little bit of space there, the square root. What's x squared squared? Because I'm not substituting in x, I'm substituting in x squared right here, right? So x squared squared is x to the 4th plus 8. And then since that is a function of x, I have to multiply by the derivative, which is 2x. We good with that? Okay, so then I want to find on B, I want to find f prime of 1. So that's going to be equal to 2 times 1 times the square root of 1 to the 4th plus 8. Okay, what's 1 to the 4th? 1 plus 8 is 9. What's the square root of 9? 3 times 2 is 6. Okay, what questions we got? All right, so the next thing is for C, we're supposed to find f double prime of x, which means I need to take my big F double prime. I need to take the derivative of my derivative here. Okay, so when I take the derivative of this one, what process am I going to need to use? Product rule, because these two things are being multiplied. And what else? Chain rule. I got to use product rule and chain rule. Okay? So, product rule. We take the derivative of what? The first. So the derivative of 2x is 2 times the derivative, derivative of the first times the second. That's the square root of x to the 4th plus 8. Plus the first, which is 2x, times the derivative of the second. So it is helpful maybe to rewrite that part, but at least think about it as x to the 4th plus 8 to the 1/2 power. That means we're going to have to, with that exponent, it's going to be 1/2, so that comes out in front, and we can have that 2 in the denominator. That's our big 1/2, right? So I take 1/2 times, then what's on the inside stays the same, and I subtract, so that's to the negative 1/2. So that means down here I get the square root of x to the 4th plus 8. Everybody with me? Okay. I can put a 1 on the top, but I'm not finished, so I don't want to mess myself up here. Then I take this, so I did the outside, and again, if you need to see it, it's x to the 4th plus 8 to the 1/2 power, right? So I bring out the 1/2, and this becomes negative 1/2. But I didn't write all that. Basically, I went ahead and skipped to the part where it's like 1 over 2 times the square root of x to the 4th plus 8, right? Hopefully you can get to the point where you did that. I just left the 1 off. Because it's the chain rule, now I have to take the derivative of what's on the inside. What's the derivative of what's on the inside? 4x cubed. Okay. Now, we could leave it like this, right? But if it's a multiple choice question, we got to make sure we can clean it up a little bit. So I'm going to leave that first part, 2 times the square root of x to the 4th plus 8. Plus, now if I look over here, these 2's will cancel out, right? And I still have this x that needs to be multiplied. So that'll give me 4x to the 4th divided by the square root of x to the 4th plus 8. And then I wouldn't worry about getting like a common denominator or anything. I don't know that that's necessary. I mean, I guess it's possible, but highly unlikely. We're good so far? So now for D, we have to find big F double prime of 1. So we're just going to evaluate this one. This is going to be 2 times the square root of, well, that's 1 to the 4th plus 8, so that's 9. Plus, it's going to be 4 times 1 to the 4th is just 4, times, again, the square root of 9 down there. So 2 plus the square root of 9, 6, plus 4/3. So we could leave it like this. We could leave it like this, but we have to know how to continue. So this could become 18/3 plus 4/3. That gives me 22/3. Okay. What questions do you have? Anything? Yes, sir. Oh, yes. All right, we good? All right, so you have the rest of the time to work on that stuff and let me know if you have questions.